22, 23, 24, 25. So we are rather up to 24, not 25. 20, that is 1. 21, that's 23, 24. 20, 21, 22, 23, 24. So we have 5. The weight is 5. Alternative way of getting the class weight is getting the difference between the boundaries. That is the upper class boundary minus the lower class boundary. So like specifically for the highlighted, we can take the upper class boundary, which was 24.5, then we less the lower class boundary, which is 19.5. Okay, now I want somebody to get the weight for the highlighted class, that is 45, the class with the limit of 45 to 59. Very fast, the class weight. The class weight is
15.
15.
15. Some are saying 15, some are saying 16. So
15.
I have said we take the lower class boundary, subtract it from the upper class boundary. So now question is, what is the upper class boundary for that class?
59.
Yeah, 59.5. We subtract the lower class boundary for the same class. What is the lower class boundary? What will be the lower class boundary?
44.5.
Yeah, 44.5. So what we do is that we take 59. Just a minute. We take 59.5, which is the upper class boundary. We less 44.5 lower class boundary for the same class. So this is 0. This is 5, 1. So the weight for the last class there is 15. Alternatively, you can count 45, 46, 47, 48, 49, hadi 59. You will see that we have 15. So that is what we call the class weight. That's what we call the class weight. Okay, having said that, let's look at now measures of central tendency, which I said, these are items like the mean, the median, and the mode. Mean, median, and the mode. That's what we call measures of central tendency. In statistics 1, we say that mean of X, as I'm sharing there, is obtained by summation of the column Fx over summation of X. We say it is mean of X. Mean of X, which is denoted by a bar, then an X. So bar, then X. That's what we call it. We read it as mean of X. We've said it is the summation of the column Fx over summation of the column F. Then the next one that we looked at in form 2 was median, where we said that for you to get the median, you get L plus N over 2 minus CF over I, where maybe we can say that N over 2 is a median position, N being total frequency. Assuming, for example, you have 50 students, so total frequency will be 50. So our median position will be 50 over 2. So median position will be 50 over 2. And note that we are talking about a position. So it will be position 25, the 25th position. L, lower class boundary of the median class. So a question would be, what is the median class? The median class is that class that has the median position. Remember, we started by saying that some data is grouped into various classes. So that class, the position 25, or where position 25 is, we call it the median position. So we take its lower class boundary. Then CF is the cumulative frequency of the class before the median class. The cumulative frequency of the classes just before the median class. Then F is for frequency of the median class. Then the letter I there is the class weight of the median class. We've talked about what class weight is. Then we have mode. Mode is the class with the highest frequency. That is the class that has appearances. Like in the previous case where we were trying to count, we see which class has the highest number. That is the mode. Then we'll talk also of model class. Model class, this will be the class with the highest frequency. So for example, if the highest frequency is 50, that is to say 50, a certain class has 50 appearances. We say that is, how do we tell which is the median class? The median class, we've said, it is the class with the median position. It is the class with the median position. Maybe we'll look at that later, but maybe to answer him, we will need a column that will give us position, because you're talking about positions. And for us to achieve this, we need a column for cumulative frequency. Cumulative frequency. So this column of cumulative frequency is adding frequencies cumulatively. And therefore, this column will be talking about positions. So using the column of cumulative frequency, which we'll look at later, we're able to see where position 25 lies, if at all we had a class of 50. I hope you are answered. Whoever had asked that, are we clear? Okay, then we proceed. Now let's look at examples maybe, so that we don't talk too much theory. Let's look at some examples. So this is what we did in Form 2. We'll be providing data in form of a table. This table here, where we have some classes. The first class has 10 to 19. Then we have 20 to 29, throughout to 60 to 69. Then each class has been given some frequency. Like the first class has a frequency of 3. The other one has a frequency of 4. The other one has a frequency of 7. We had 15, 11, then 5. So that's what maybe you will be provided with. Sometimes these will be missing, like we saw when we were introducing. Given the raw data, then we are told to look for these frequencies. But in some cases, you will be provided with the data that has classes as well as their frequencies. So here, we want to get mean of X. We want to get mean of X. So in the beginning, we said that for you to get mean of X, whatever I've circled there is the formula. That mean of X is equals to summation of Fx over summation of F. Summation of Fx, summation of F. So I started by saying that the highlighted step there is what will be given, where the data is grouped and each frequency provided. Now the formula is telling us that we need to get summation of Fx over summation of F. Needless to say, we will require some columns that will be talking about the formula. The formula has summation of Fx, so that means you will need for Fx. We need a column for F. And even before we go to the column Fx, there is something mentioned there, X. So we'll need a column with a column with F and a column with Fx, like I have worked it out there. So your work, first of all, is to create a table with several columns. The first column, put the marks as provided for in the table above. The marks as provided for in the table as per the classes. The first class, 10 to 19, 20 to 29, 30 to 39, throughout to the last class. Then we did a column for X. As you can see in the formula, we need a column for X. Maybe because we've done this before, how do we get X in group data?
You can add the midpoint of the class.
Yeah, that is correct. You get midpoints of each class. You get midpoint of each class. Remember, if, for example, the first class here, we have 10 to 19, we have 3 items that were under that class. If, for example, is an exam, watu watatu ndio walipata 10 to 19. We don't know whether they had 11. We don't know whether they had 17. We don't know whether they had 15. So to be safe, we use the midpoint of that class. It will represent the 3. So the assumption is that the 3 had 14.5 each. So that's why we are using a term that will somehow represent everything from that class. We take the midpoint, we take the center. And that's why in some question, they will tell you estimate the midpoint. Estimate meaning we are getting some estimate. We are getting some estimation because chances are the people in the 10 to 9 class had 18s. So we were supposed to take 18 multiplied by this so that we get the total marks. However, we are not sure whether they had 11. We can't take 11, we can't take 18, we can't take 16. We take a mark that will be fair. That is the midpoint for that class. At least can give you some representative of the whole class. So we take X for each class. The next class will be 20 plus 29 over 2. That is the midpoint. Then we have 30, 39 divided by 2, which will give you 34.5. 49 divided by 2 to give you 44.5. Through up to 60 plus 69 over 2. Divide that by 2. Give 64.5. Then the column for frequency, you just transfer it as it was on the first class had 3, 4, 7, 15, 11, 5. So we just transfer it that way, 3, 4, 15, 11, and 5. Then the last column, as per the formula, has to get summation of the column Fx. So then it necessitates that we create a column Fx. And this Fx will be the product of the column X and F in each. We take X in each row, multiply by F in that row. Like in the first row, which is having the class number 1, it will be 14.5 by 3 to give you 43.5. Hope that is clear.
Yes.
Okay, so we proceed like that up to the last class, which has 60 to 69 and 64.5 as the midpoint. So our X will be 64.5, multiply that by 5, so that we get 322.5. So our objective was to make sure that we follow the formula. The formulas told us that for you to get mean of X, we need the summation of the column Fx over the summation of the column F. So I had calculated this one, and it gave me that summation of Fx was 1972.5. So that will be my numerator. Summation of F was 45. So that gives me my denominator. So eventually I have 43.83 recurring as the estimate for mean of X. That will be the estimate for mean of X. That was just a review. We did that in statistics 1. So I don't need to overstress on that. Maybe what I will overstress is something that now will be introduced in statistics 2. Something that will introduce in statistics 2. I believe I'm still sharing the same thing. Just a minute. Now in statistics 2, we introduce something called assumed mean. Maybe you can write somewhere assumed mean. Assumed mean. Maybe before we look at how it works, we can give the reason why we may use an assumed mean. In the previous example, I hope you're able to see the screen.
Yes.
Okay, in the previous example, you noted that every row we were multiplying f by x being the midpoint of each class, and f being the frequency. Now, without calculator, it was hard for you to get the product fx, which is even harder to get sigma fx, making it even get sigma fx over sigma f. That is if you do not use calculator. Now, when there were no calculators, maybe it was easier to simplify that. But now we are using calculator. It is also needful that we do not over-rely on the calculator. Hence, the introduction of the assumed mean. So assumed mean basically is to help us not to over-rely on calculator, so that we can use the simpler numbers to calculate. So when we were getting a mean of x using the normal method, we said that the formula was sigma fx over sigma f. That was the normal method, was from statistics 1. Now, when we get to statistics 2, that is now from 4 work, we will make use of assumed mean like I have mentioned, after which we are now going to get a mean of a different item. Remember, we were getting mean of x, that is bar x in form 2, which was sigma fx over sigma f. So here, we make use of some assistance, maybe to simplify our working. We will create something different, like I have maybe circled. Can somebody read for me what I've circled?
T equals to
The mean of
sigma
t
ft divided by sigma.
Yeah, that is correct. That the mean of t is sigma ft over sigma f. So in a way, it resembles what we did in form 2, looking for bar x, or the mean of x, which we obtained as summation of fx over summation of f. Now, with assumed mean, we look for a different term, which will later incorporate so that we get bar x. Remember, our intention is to get bar x, not bar t. But we can use bar t to simplify our working. Now, what is this thing that we are calling t? T, as seen in the highlighted bit, is each mark subtract the assumed mean. We make an assumption. We have the data there, then we make an assumption. What could be the mean of this data? Without calculation, we make an assumption. We come up with a number that could be an estimation of we don't get any information, or rather, our guesswork is not informed by anything. It's just looking at the data and making an assumption. Like in this question, the assumed mean is 44.5, which is not based on any calculation. Maybe you just observe the data and assume that the mean could be 44.5. So how do we go on creating? do we go on now creating the column T so that we make use of column T? And I've said the purpose here is to make sure that our working is simplified so that we do not over-rely calculator. So like in statistics 1, we'll have a column for mark. Then we'll have a column for a mark that will represent the class, that is X. Then we'll have a column for frequency. So that one does not change when you're making use of the assumed mean. Now our new creation here is this thing we are calling T. And we get T by saying each mark less assumed mean over the class weight. Each mark less assumed mean over class weight. Maybe I can write that. We've said that T is equals to X. X ni nini? X ni ile column ya X hapa. Ile column ya X. We minus the assumed mean. This capital A is the assumed mean. And in this case, tulikuwa tushasema ni 44.5. Then we divide it by as weight for each class. So that's how we get T. Maybe we will appreciate it if we use an example, or rather we work it out. So let's look at row 1. In our row 1, the class where we had 10 to 19, our midpoint, that is X, was 14.5. Our frequency was 3. So our T will be, we'll get our T by saying 14.5, which is X. We minus the assumed mean. Assumed mean we had been given. It was 44.5. So we minus 44.5. Then we divide that by the class weight. What is the class weight for the first class?
10.
So we divide it by 10. Now, what is the difference in our numerator? 14.5 minus 44.5, what do you get?
Negative 30.
So negative 30, then you divide by the class weight. The class weight is 10. What do you get?
Negative 3.
Negative 3.
Now that is the negative 3 I had put on the column T in the first class. We've said X, which is 14.5, minus the assumed mean, which is 44.5. Then you divide that by the class weight. You get negative 3. So we do the same for the next row. The next row is the row that has 20 to 29. So our X in this case will be 24.5. So our X is 24.5. Our A, capital A, has not changed. It is the mean that we had assumed that it was the mean for the data. Then we divide that by class weight. Class weight, your second class me. Yeah, we stay on mute. Unless you are responding to a question.
When Ray.
Okay. Now we want to look at the T for the second row. We've said it is the row that has 20 to 29. And the X for that row is 24.5. So we say that 24.5, we minus 44.5, where 44.5 is our assumed mean. Now, the question was, because we are supposed to write that by the class weight, what is the class weight for the class 20 to 29? We get 10. We get 10 by saying 29.5 minus 19.5. Remember, we started by saying how we get a class weight, upper class boundary, less class boundary for that specific class. So we get that our weight is 10, and that's why we are dividing by 10. So what is the difference in our numerator?
Negative 20.
So negative 20 we divide by the weight is 10. We end up with negative 2. So that's why I had put negative 2 in the second row in the column headed by T. Now we go to the third row, the row running from 30 to 39. Maybe we should first of all erase this. The row from 30 to 39. Our X, which was the midpoint, is 34.5. So that represents the whole of that class. That is a mark that will represent the whole of that class. So it is our X in the formula of getting T. So we say 34.5. Then we minus our assumed mean. Our assumed mean was 44.5. Then we say over the class weight. Again, what is the class weight of that row, 30 to 39?
10.
It will be 10 because it is 39.5 U less 29.5. So what is the difference in the numerator?
Negative 10.
So negative 10, then we divide by the class weight being 10, you end up with?
Negative 1.
Negative 1. Again, that is why I had put negative 1 on that row on the column headed by T. So my T in that row is negative 1. Then we go to the next class. It is the same procedure. So we'll have 45.5 minus 45.5. So in our numerator, we'll get 0. So 0 divided by 10. 10 because the class weight for that class is 10. So I end up with 0 in that column headed by T. The next is 50 to 59. So what is my X in that class? What is X?
55.5.
50? 54.5. So that is my X. So I put there 54.5. A has not changed. It is still the same assumed mean we were using above, 44.5. Then I divide by 10 because the weight for that class again is 10. It is 59.5 U less 49.5. So you end up with the numerator being 10. 10 divided by 10, you get 1. So that's why I have the 1 here in the column headed by T. Then lastly, we have 60 to 69, where my X is 64.5. My X is 64.5. Then I subtract the assumed mean, which is 44.5. Then I divide all that by, again, the class weight. Our class weight is 10. So I end up with 20 over 10, which will give me 2. That's why I had put 2 in that column headed by X for that row 60 to 69. I hope we are okay with how we are creating the T.
Not really.
Where did you get lost? Or where did you not get it?
Mburu,
Yes.
hope we are still moving on.
Yeah.
Maybe I can respond to whoever is asking.
Mm-hmm.
Just as we did last week, we are still together here. Maybe I'm just thinking. If we had worked it before we introduced the T and then but because the T is already here with us, do I have the right to share anything?
Yeah,
have you finished the example first? Let me not interfere. Have you finished the example?
I was just asking how we are getting T. The example is not yet done.
Oh, it's not yet done.
Yeah, maybe.
Okay, just finish. Just first finish.
Come in later.
But maybe whoever was asking, Mwalimu is just trying to make the manipulation of X simpler and simpler. He worked out the assumed mean. And from the assumed mean, he realized the number that he got is still large to manipulate. So even to make it smaller, he divided by a constant. And that constant is most of the time the class width of the class. So for those who ask you where the T came from, if you look at the first class from 10 to 19, the class width is 10. So it's simply divided by 10 to make the number even smaller for purposes of manipulation. Same to the next one. So anytime you're looking for T, you get the value of X, you minus the assumed mean, and then you divide by the class width. And there is nothing special about what width you are going to use. You can divide by 10, you can divide by 20, you can divide by 10, by 2. The idea is to make the final number that you are working with smaller and simpler to manipulate often, even without a calculator. It is easier to multiply 3 by 3 than to multiply 3 by 22.4. So that is the idea. All right?
Yes, thank you.
Are we getting it, guys?
Yes, thank you.
Yes. So somebody's asking, Mwalimu, the A we are using, kindly explain how we get the A. The A we are using is what we call assumed mean. Mr. Mburu, would you allow me to go back slightly to the assumed mean before we finish the example?
Okay, proceed.
So guys, just hold there so that I answer this guy who's asking, because if we keep moving and we have not understood where the T, the C, and the A is coming from, then I'm sure we are leaving some behind, although I still believe most of us, we are moving together. So, the A that Mr. Mburu is using is an assumed mean. Maybe to make it clear, allow me to share something, Mr. Mburu, please.
Yeah.
Then we just hold on the example there. Do we have the right now?
Yeah, proceed.
Now, just look at these guys. I don't know whether it is showing from your end. Are you seeing anything I'm displaying?
Yes.
Yes. Yes.
If you can see something I'm displaying, it's just introduction to this statistics 2. And in the introduction, if you look at what I have, it is just what Mwalimu was discussing with you. I want to remove this thing. There's something here that I don't want. It is what Mwalimu was just discussing with you. Sorry, I'm still trying to operate this. Yes, this is what I was looking for. So you started by looking at the formula for mean, which is just a very basic, as I've shown there, but I don't want to go all those things because I was listening to what you are doing, and you have done everything up to this bit. This is where now, after this place, now you shifted. So let me start here. This is what you're asking, the issues of about assumed mean. Assumed mean is used to make working of large numbers easier. And that is exactly what Mr. Mburu is saying. We want to make the numbers friendly to manipulate. Now, consider the numbers are picked here. I have 717, 711, 718, 719, and 715. And I want to work out the mean of that number, or the mean of those numbers. To work out the mean of those numbers, logically, I'll take the numbers, I add all of them, and then I divide by 5, because the numbers are 5. So when we do that operation, what is the mean?
716.
It is 716. Please pick that, because it's what I want to use now to bring the concept of assumed mean. 717 plus 711 plus 718 plus 719 plus 715. When I add all those numbers, I'll get 3,580. And when I divide by 5, I'll get 716 as the mean of those numbers. So how do we now employ the concept of assumed mean? Now look at this. No, let me first remove this. Let me first clear this. Now look at this, the next level of just the same numbers. Now, looking at the same numbers in the second category, I'm now saying, if I rewrite this number, instead of writing 717, I write 700 and I add 17. The next number was 711. I write 700 and I add 11. It is still 711. The other one, it is still 700, 700, 700. So the first number was 717, 711, 700. So there's a constant that you are seeing mathematically from the maths we know in Form 2, that I can factor out the common term in all those 5 numbers. And the common number is 700. So I'm factoring out this 700, but I realize that 700 is appearing how many times? 5 times.
5 times.
There's 700 here, there's 700 here, there's 700 there, and there's 700 there. So the 700 is appearing 5 times. So if I want to know the total of the 700s, it will be now 700 times 5, which gives me 3,500. Then I add the other numbers on top. Let me use a blue color. There is 17 plus 11 plus 18 plus 19. So those are the numbers on top of 700. So when I add them, they give me 80. 80 of them. Then I wanted to find the mean of those numbers or that number. I realized the 700 times 5 is like 3,500 divided by 5, which will give me 700 again. What does that tell you? The mean of a constant is the same number. For example, if I give you 5 plus 5 plus 5 and I tell you work out the mean, what will be the mean? Just one person to speak. 5 plus 5 plus 5. What is the mean?
5.
5. So 700 plus 700 5 times divided by 5. What is the answer? It is still 700 because maybe you guys are not talking. So in other words, we are saying if I choose any constant, I'm not trying to bring the idea of assumed mean. Oh. Somebody's breaking up. Okwero, Derek. Okwero, Derek. Yes, good. So I'm saying, if I take any number, even if it's 10 plus 10 plus 10 plus 10, divided by the number of tens, the answer will still be 10. 4 plus 4 plus 4 plus 4, whatever number of times, the mean is still 4. 2 plus 2 plus 2 plus 2, the mean is still 2. So we usually say the mean of a constant is always the same number. It will not change. It's like in your exams, if you do 8 subjects and every subject you get 70, what will be your mean? It still be 70. So the mean will not vary. So if you look at the working that I've done here, I've simply taken a number. I fixed one of the number to be the mean of that data, 700. Then I'm left with smaller numbers to add, like 17, 11, 18. And then I work out the mean of those numbers on top. I would have taken another number like 500. Then it would be 500, 500, 500. The mean of 500, it still be 500. Then plus the mean of what is on top of the 500. Even if this number, it took 710, then it will be 710 plus 710. The mean will still be 710 plus the mean of what is on top of the numbers. So if you give me any number, for example, you give me 21, 23, 22, and you ask me what is the mean, I can assume the assumed mean is 20. So I'll take 20 plus the mean of what is on top, 1 plus 3 plus 2 divided by 3, and that will be the mean. So anytime we are introducing the concept of assumed mean, we just pick a number within the same numbers that we're dealing with and assume it is the mean, because the mean of a constant is the same constant. and then work out the average of what is either above or below the number that I had assumed is my assumed mean. And if you look at the working down here, that is now the genesis of the formula for assumed mean. Look at what is down there. In general, the constant is known as assumed or working mean, denoted by the A that you are asking. And the difference or the differences are known as the deviations. And that's why the deviations are denoted by X minus A. So how do I get the mean? It is always that assumed mean plus the mean of the deviations. And that is what is worked out here. I need an assumed mean, then the average of the deviations from the assumed mean. A classic example is what we got up there. We assumed every number is 700, 700, and the mean of 700 becomes 700. Then plus the mean of what was above 700. And that is the concept of assumed mean. The way Mr. Mburu have said, the concept is simply to take a number that will make the manipulations friendly. There is nothing special about the assumed mean. You can pick an assumed mean and make your work more complicated. I don't know whether, guys, now you are getting the concept of assumed mean. You can chat if you have not found the whatever. Is the assumed mean constant, or it can be any value that fits in all the numbers given? No, assumed mean can be any number, but sometimes you take the assumed mean with some logic. I was just reading that from a chat. For example, if I give you numbers like 25, 29, 42, and maybe 73, I cannot say the assumed mean is 300. Now, you see, this is not logical, because even in the numbers that I have here, there is no 300. But if I assume the assumed mean here is 30, that makes a lot of sense, because 30 will leave me with 5, 1, 12, and I think 43 to work out as the mean of what is above the assumed mean. Sorry, let me see another chart. Very good. I can see somebody say now we are good. We can proceed. Mr. Mburu, please take over from there.
Okay. Somebody else is asking.
Mr. Mburu, before you take on,
Yep.
may we carry out the roll call, please?
Okay.
Kindly. So look at your screens, boys. Confirm your class very quickly. At 190, we still have around 20 boys. Close 20 boys have not filled. It's 194 now. Faster, 196. About 20 boys still waiting. 197, this one is from Q. 98. Okay. It's 199 and 200. So we stop at that. Thank you. Malim, you can go on.
Okay, we proceed. Question was asked whether assumed mean can vary. Assumed mean should not vary. Whatever you've taken to be your assumed mean should be constant throughout all those rows. If I've taken to be 44.5 to be my assumed mean, I should be consistent throughout my calculation. And maybe to mention, in most scenarios, the assumed mean will be provided for in the question. It will be given in the question. So they will tell you, taking assumed mean to be this number, estimate the mean of the. So they will give you the assumed mean. In a situation where they don't give you, maybe you can use what Mr. Mbidi is saying. Use a number that is logical. Use a number that is likely to be workable. Okay, Nimrod had his hand up. You had a question? Okay, let's proceed. We had finished calculating T. We had finished getting up for every row, and we said the need for creating T is looking up, or rather coming up with some numbers that we can easily work with. Getting fx without calculator is tedious. So we try to make sure that we have numbers that we can even calculate without using calculators. Okay. Now that we have our numbers, we have f and t. We have 3 by -3. You see now, this one you can calculate offhand. Get that ft is -9. We don't need to over rely on calculator there. The next is 4 by -2. We get -8. Again, no need of over reliance on calculator. We go all the way to the last class, which had 5. T for the last class was 2. So that now we get ft to be 10. Now mean of t, in one way or the other, resembles how we looked for mean of x. We said that mean of x was the summation of fx over summation of f. But now, because we're interested in mean of t, we'll not talk about x. We'll now talk about t. T. So we get the summation of the column ft over the summation of the column f. And we can easily count these. They're not very huge numbers like we saw when we got fx. Whatever we have in the column ft can be calculated without the need of a calculator. And my calculation gave me -3 to be my sigma ft, that is summation of the column ft. Then my summation of f is just the way we did it in statistics 1. We just put together the f, the total sum of f. Sometimes it is called n. So how many items do we have in total? N or sigma f. So I'll get that my mean of t is -3 over 45, which eventually will give me -1 over 15. That is mean of t. That is mean of t. And how did we get t? T, we said it is d, which Mr. Mbidi is calling deviation from the mean, which is x minus a. How far away from the assumed mean? Then we divide by a constant, class width in this
Mr. Mburu,
case.
can it be bigger? Can the screen be bigger, kidogo? Mr. Mburu, can it be wider?
Just a minute, I changed
using a very small part of the screen.
Is it better now?
Yes, that's better, Malim. Thank you.
Okay, so we proceed. We were saying that our mean of t, which will be given by sigma ft over ft, is -1 over 15. And we all know now how we are getting t. Our intention is to make sure that we work with numbers like you've seen. ft, to give you f, the product f, is numbers that we can calculate offhand. However, the question had told you to get the estimate of the mean of the data, which we call bar x. So our mean of t is not our endpoint. We need now to get what is bar x. What is the mean of our data? So bar x. We go back to how we got our t. T was obtained by x minus a over I. So that is a t. So if you are to make maybe x the subject of that formula, we'll multiply by I, then we add by, a. If you are to make x the subject of the formula here, the place that I've highlighted, if you are to make x the subject, what I'm saying is we now have t. How can we go back to x? We just make x the subject of the formula. Here, the highlighted bit, we have mean of t. How do we use this mean of t to go back to the mean of x? So we are going to take the assumed mean, then we add the mean of whatever deviations we had. So we take that mean of x is equals to the mean of t that we had obtained, multiplied by the constant we were dividing with. Then we add our assumed mean. Like the way Mr. Mbili had talked about, if we had taken the mean to be 20, 20, 20, then we had another 1 plus 3 plus 7. We take the mean of the 1 plus 3 plus 7, then later add the 20. So that's why we are having plus a after that. So the t, the t with a bar times I, we are trying to get back how we got our x, or rather how we got our t given x. Now we want how to get x given t. So we say that the mean we had obtained for t, which is -1/5, we multiply by the constant we were dividing with. The constant was the class weight. Then we add the assumed mean. So we end up with -1/15 times 10 plus 44.5, which will eventually give us 43.83 recurring. Tuko sawa sasa?
Yes.
Could we do another example?
We can look at another example, or maybe I can give you an example. You try it on your own. If you look at the mean we have obtained here.
Mr. Mburu?
Yep.
Maybe I can respond to a question I'm seeing in the chat as we move on. Somebody is asking, in case you are not given the assumed mean, can you use the normal mean, which is given by fx divided by summation of f? The answer is no, you cannot use that. Remember, we are looking for the mean. And then we are using a method that will assist us to get the mean easily. So the moment you ask whether you can use the normal mean, which is given by summation of fx over summation of f, you've already got the mean, or you already gotten the mean. So there is no other mean to calculate. So whoever is asking that question, you already got the answer. Remember, when you are using a calculator, you can compute large numbers. So that fx over f is already the mean, so you don't need to look for it again. Then there's another question here. Somebody's asking, because we are using tables, how does the assumed mean work? Very good. As just Mr. Mburu has explained, using his table there, you look at the data given. Let me refer to the midpoints given here now. The midpoint is 14.5, 24.5, 34.5, 44.5, 54.5, and 64.5. To get the assumed mean, because you want to make the numbers easy to work with, you assume a number that will make the deviation an easier number to work with. For example, if we use 34.5, the deviation becomes -20. But if I use the deviation to be 30.30, the deviation becomes negative. I think it will be -20.5. And now 20.5 becomes more difficult to work with. So you assume a number. It's good to assume a number within the given data sets, but a number that will make the deviation easier or simpler to manipulate. I can see somebody says, teacher, explain how you get x. X is the midpoint of the class. For example, the first class is 10 to 19. So when I look at 10 to 19, I'll take 10, I add 19 and divide by 2. That becomes the midpoint, which is our x. Somebody is asking, can the class weight vary? Yes, the class width can vary. You can have a class width of 10, 15, 25. They can vary. But once you choose as an assumed mean, you use the same assumed mean for all the values of x. But the class width can vary. Somebody is asking that. I think I've addressed all the questions that I'm seeing in the chat. Okay, over to you, Mr. Mburu.
Okay, maybe.
Unless there's somebody who wants to ask a question verbally.
So what is the meaning of that bar there?
Sorry?
Above T and above X. What is the meaning?
It's not clear. It's not clear, maybe.
He is
Project-
asking the meaning of the bar that is above T and X.
Okay. The meaning of the bar above X. Hello?
Yes, above X. And
Ah,
above
very good. That is the symbol for mean. That's how we denote mean. Instead of writing the word mean, we write the mean of X. So we write X bar to denote mean. And I think that is what I was sharing, the slides that I was showing you. There's something I had written. I don't know. Mr. Mburu, can I share again?
Yeah, just a minute.
Uh-huh.
Proceed.
I don't know whether it's still, I think it is still here. If you look at the introduction that I was giving you, let me go back again. Look at my introduction here. If you read the introduction, I said, can somebody read that loudly? One of you read.
We will begin by stating the meaning.
We'll begin by stating the meaning of
Some
some useful notations in statistics.
Yes.
And the notations are given there. Number one, the sigma notation. This is represented by the symbol, that symbol, which is a Greek alphabet, and it is used in statistics to mean the sum. So there are symbols we use in statistics, that's one of them. Anytime you see that symbol, we are telling you add, just add the sum. Then there is the other number 2 there, X, which is used to represent the mean of a data set. So anytime you see that symbol where you have an X, even if it's a T and a bar, an M and a bar, a K and a bar, this bar in statistics represents the mean, is the symbol that we use as statisticians to denote what you are working out. The way somebody can say, I don't know what other symbol represents for something.
Just take it. It has no
You
charge.
get it, eh? Good. Let me see if there's another question in the chat. Is the assumed mean coming from the class with the highest frequency always? Not necessarily. Not necessarily. In most cases, is the class that is almost in the middle. Remember in Form 2, we did measures of central tendency, and we said mean is a measure of center. So if I give you, if you get mathematics 20% and you get history 80%, what is the mean? The mean cannot be 20 and cannot be 80. It should be a number in between the two numbers because it's a measure of central tendency. So we always choose a number which is almost at the center of the distribution. Then somebody is asking, what if the class width for the classes vary? What do you use as X minus A over I? If the class width vary, for example, let me write here. If one class is 9 to 10, to 15, another class is 16 to 30, and you decided to use the width of the first class, you use the width for all the others, you will use the same. If you choose the width is 2, you use 2 for all the others. And that's why Mr. Mburu say if you are looking for T T is x minus a over a constant. That's why it's a constant. It should not vary. If I choose my cursor to be 3, I'll use 3 for every other calculation. If I use 7, I'll use 7 for every other class. If I use 10, that's why it's a constant. This cannot vary. If the first class I use 5, then it uses 5 for the rest of the classes. Yes, that's somebody who was asking whether that should vary. Let me see whether there's anything else. No, I think that summarizes what I can see here. Then what does, somebody's asking, then does mean that the answers will vary? No, they will never vary. They will never vary. The means will remain the same. Please, let me show you something. I think there's something that, guys, it's giving you some stress kidogo here. If I gave you numbers like this, let me give you simple numbers like 11. No, let me annotate this. If I give you numbers like, so that you see what you are saying. If I give you numbers like 11, 15, 20, and the 22, give out the mean of that number. Work out the mean. Just give me the mean in a second. There's nothing to you're working out there. What's the answer?
34.
30? That what? 34.
That's so.
The mean you added all the numbers. What was the total when you added?
54.
54. No, this can't be 54.
No, this can't be 54.
58.
64.
64 divided by?
68.
Hey, you guys, you don't know what you're saying. 68 or 64 divided by 4. So what's the answer?
17. The mean is 17.
17, eh? Now, let's now come here and they say that we want to work out the mean, and the assumed mean is a number like 18. The assumed number is 18. I will say that the mean will be 18 plus the sum of the deviations from 18. So what is 11 minus 18?
Negative.
Negative 7. What is 15 minus 18?
Negative 3.
Minus 3. What is 20 minus 18? 2.
Plus 2.
What is 22 minus 18? 4.
4.
Add all those numbers, divide by 4, and tell me what is the answer.
Negative 1.
Negative 1. What is 18 minus 1?
17.
17. So the mean is still 17. So if I changed and I said, now let me say the assumed mean is 50. So that you see what I was saying. You are trying to make it complex when you assume a number that is very far from the other numbers. It will be 50. So what is 11 minus 50? Is it minus 39?
Yes.
Plus minus 35?
Yes.
Plus minus 30? Plus
Yes.
minus 28? Divide by 4. What is the final answer?
Negative 33.
No, tell me the answer is 17. 50 plus minus 33 is 17. 17. Now, looking at this data, when I add direct, the mean is 17. When I use assumed mean of 18, the mean is 17. When I use assumed mean of 50, the mean is 17. But out of the 3 operations, which one looks easier? Of course, the second one.
Of course, the second one.
Because you just took 18 plus 1. I mean, 18 minus 1, which gave us 17. And that's why Mr. Mburu said the work of assumed mean is to make these manipulations, these numbers easy to add as compared to what I have given down here, or as compared to the raw data. So you can assume any number to be the assumed mean, but be consistent. If I assume the assumed mean is 18, then I'll go subtracting 18 from every number for consistency. If I assume the assumed mean is 50, I go subtracting 50 from every number for consistency. So I don't subtract 50 in one number and the 20 in another number. No. The assumed mean is a constant. That's why I say the mean is given by that assumed mean plus x minus my assumed mean divided by a certain constant, x. A is fixed, C is fixed, but x is the number that keeps changing now. It's our variable. Let me see, I can see other somebody change. The teacher said x minus x times that now, the x is the constant. Please explain. Mr. Mburu. Mr. Mburu, are you still there?
Yes,
Please clarify. Can you see the charts?
I can only see once, maybe in the general chat forum. Maybe
There's
they
one
had
who
it-
is asking, there's one who say, although I know that one maybe, he's saying
Mhm,
x, you said x is equals to t
mhm,
times I.
mhm.
No. Mwalimu, I mean, maybe the typing, because I'm
Mhm.
sure you did not say that. The concept
may-
is this, whoever is asking that, t is given by x minus a. Unless, let me see the formula. Mwalimu, you can share so that I respond to something that I can see. Or you can just respond to it. There's somebody who is saying, let me write what somebody is saying. He say you
Mhm.
said x is equals to
Hello? I hope audible. Can you hear me?
Yes.
Yes, we can. Yes.
Let me try to see what maybe the question was. Whoever is asking maybe asked whether x is equals to ti plus a. I believe that's what the teacher was saying. That is what I got. However, what I said was mean of x. Note that we have a bar above x. We also have a bar above t. So it is not the same thing like what the teacher was reading maybe before we lost his audio. T is equals to x minus a over I. That is how we got our t. So if you want to get x from t, you reverse. Yes? You reverse that process. The process was x minus a over I. So we want to get x. So the reverse of division is multiplication. That's why I'm taking t multiplied by I to reverse this process where I was saying over I. Remember, I'm going back. To get t, it was x minus a over I. So if I already have bar t, I want to get bar x, I will reverse the process. And the reverse would be multiply by I, then add to a. I hope it is clear. Whoever had asked that question. Is it clear?
So when you're getting the summation of
the mean of t.
Yes.
I'm asking when you're getting the summation of x using that ci plus, that is the total of the mean of the data or the midpoint.
When you're getting a summation of
X.
When you're getting summation of x, remember we get summation of fx when we were not using assumed mean. When we are not using assumed mean, ndio tunatumia sigma fx.
Sorry, I meant mean. Teacher, I meant mean, like mean, the one you've written right now, the mean of x. So that is the mean of the data or the mean of the midpoint.
So this bar x we have here. That's what you want to get clarity on?
Yes.
So whatever I'm now sharing is a mean of x is equals to mean of t times the I plus a. Already we've gotten some mean of t. How did we get mean of t? Mean of t was obtained by sigma ft over sigma f. So we were using the t column and the f column so that we got mean of t. Then later we added to assumed mean. So it was mean of t, sigma ft over sigma f. So it was t multiplied by f. T multiplied by f in each case. Is that clear?
Okay, so the mean of x is the actual mean.
Yeah, now the mean of x that we have here is the actual mean. In fact, if you are to compare the question we started with from statistics one that we finished with, the means are the same. So that is the mean of our data. Whatever we'll have there will be the mean of our data. Whatever I have highlighted there, mean of x is the mean for the data. Here, that is the mean for the data. This here, the one that I've circled, was mean of t. And you remember how we got t? We got t so that we can simplify our working. So the simplification of the work would eventually not give us the mean of x unless we come later and make x the subject of our formula. So whatever is circled there was the mean of the additional things. Then we add it to the assumed mean so that together they'll give us the mean of the whole set of data, that is bar x. That is clear now?
Yes.
Okay. I don't know whether Mr. Mbidi, you are back?
Sorry, nilikuwa nimepotea.
Yes.
And maybe for just clarify, what we can do, Mr. Mburu,
Yes.
is you can now give them another example. And before we introduce the t, we just use the deviations. Then the answer that we get from the deviations, we introduce the t so that they can now see that link. Then, however, I can see also some I think it's a misspelling here, so that in the future they don't take this to be the correct. This class is class width, the class width or weight, the width, the size of the class. So it's okay. I can see the rest is okay. You can now finish with the example.
Somebody is asking, excuse me, the class width is different. Does the value of I, which you use in calculation of t change, or do we use a constant value? We should use a constant value. We should use a constant value. Like the teacher had explained, if you decide that my constant is 5, be consistent, use 5 throughout all the classes. Okay, I hope that is clear now. And maybe we will have a take home so that we can finish the lesson for the day. I see we only have 1 minute. We can take some question, maybe from KMF, and maybe try and see whether we can calculate that. Take some random data. I believe a majority of us have KMF. If you do not, we have those who have KMF. Let's look at what was done 209 paper 1 number 18. 209 paper 1 number 18. Okay, maybe for those who don't have KMF, I can read the table very fast for you and write it down. We have 0 to 9, frequency is 1. We have 10 to 19, frequency is 2. 20 to 29, the frequency is 4. 30 to 39, 7. 50 to 49, we have a frequency of 10. 50 to 59, frequency 16. 60 to 69, frequency 20. 70 to 79, frequency is 6. 80 to 89, frequency is 3. Then 90 to 99, the frequency is 1. I hope you've gotten the data correct. For those with KMF, it was done 9, paper 1, number 18. 209, paper 1, number 18. Part D, using an assumed mean of 54.4, calculate the mean mark. Using an assumed mean of 54.4, calculate the mean mark. Using an assumed mean of 54.4, calculate the mean mark. So I believe that will be a very good takeaway, rather take-home assignment for us, so that we ponder through it throughout the week. Then maybe we can look at it together as we do the other measures of central tendency, maybe in the next class. Unless, Mr. Mbidi, there is anything?
Not really. I think you have exhausted. Can you stop sharing? I write something. Maybe as they do the takeaway, they compare. Yeah, they compare the following. I want to share maybe a blank screen.
Proceed.
Okay. I'm saying that question that Malim has given you, you can do this. You can do the same question using, number 1, the formula for mean is given by summation of fx over summation of f. Start by that formula. Then number 2, use the formula mean is given by, is given by assumed mean plus summation of fd over summation of f. Then number 3, just do the same question, but using assumed mean. Mean is equal to summation of ft over summation of f, and then you multiply by the constant. If you use those 3 approaches, the answer will be the same. If you don't get the same answer, let's pick it from there when we meet next. But you know, the idea of these sessions is to make you read ahead and see things from your perspective. So we are just giving you guidance. So if you can now work that same question using, not necessarily about what is given there, it's more about understanding more details. Use the first formula, see what answer you get. Use the second formula, see what answer you get. Use the last formula. If all of them give you the same answer, then you're okay. If they don't give you the same answer, now we'll be in a position to address your questions from a point of information. Thank you very much, Mr. Mburu. You can summarize as we come to the tail end of the lesson.
So if you already give an assumed mean, then you use another mean, will you get it wrong?
Sorry?
You already given an assumed mean, but the difference is big.
The difference is big.
Then you use another mean.
No. Use the. If I got what Malim was reading, he gave you the assumed mean to use. So use the assumed mean that you were given. Don't change it. But purposes of exploring, you can keep adjusting for other questions, or even for the same question. You can try with the different assumed means and see whether the answers are the same.
Excuse me, sir.
Thank you.
Yeah. Yes.
I'm asking. This constant, we said it must be constant in here. Now, must it be among the? Must the number be among the class weight of one of the classes?
Yes, it's advisable, although it's not compulsory, but it's advisable. It's advisable to use the class width of one of the classes. Are we together there?
Yes. Yes. Thank you.
Okay. But Mburu, I think we are almost done.
Yeah. Thank you very much for your availability, and see you in the next class.
Asante sana.
Thank you, Mwalimu.
Thank you, teachers of mathematics. You've done great, and do have a nice afternoon, and your families too. Wanafunzi, asante sana. You can now have your holiday time. Let's meet tomorrow morning.
Thank you, sir.
Thank you. Wait, walichukua roll call.